All right, so today we're diving deep into large language models, LLMs. We've got excerpts from a research paper. It's got a ton of insights about how they're built, what they can do, even the wild hardware they need. And I bet you use LLMs every day without even realizing it.
Yeah, that's probably true. Personalized recommendations. Those chatbots that seem almost, well, human.
It's kind of freaky how real they seem sometimes.
It is. What's fascinating to me is that LLMs aren't just processing words. They're designed to actually, get meaning and context.
Just like us?
Exactly. Which is how they can generate that nuanced, human-like text.
It's wild how far these models have come. This paper takes us way back to, the 1950s, those early rule-based models.
Ah, yes.
It's remember those choose-your-own-adventure books?
I do.
Kind of like that, with pre-programmed responses based on very specific inputs.
Yeah, those early models were definitely limited. They really struggled with the complexities of human language, all the ambiguity, like trying to fit a square peg in a round hole.
Right.
But then came statistical models. They were a game changer, using huge amounts of data to actually find patterns in language.
And that's when things got interesting, right?
Yeah.
Instead of rigid rules, they were learning from the data itself.
Exactly. It's like instead of memorizing phrases from a book, you're actually immersing yourself in the language.
A much better way to learn.
For sure. And statistical models did a great job, predicting the next word in a sentence.
Right.
But still not great at understanding that deeper meaning, the context.
And then, in the mid-2000s, word embeddings.
Another big leap forward.
Big time. Instead of words as, these isolated things, they were represented as vectors, capturing relationships in multidimensional space.
It's like mapping the entire vocabulary of a language onto a star chart.
Oh, I like that.
And the distance between words shows how semantically similar they are.
That's a great way to visualize it.
So yeah, word embeddings. AI could start to grasp those semantic relationships, a huge step towards understanding language more holistically.
So we went from those rigid rules to statistical patterns and then to semantic maps. What came next?
Well, that's when neural language models came into the picture.
Yeah.
Especially the ones based on the transformer architecture. And this is where we see models like BERT.
Okay.
And of course, the GPT series.
The ones everyone's talking about.
Exactly. Capable of generating that remarkably human-like text.
It's crazy to think about how fast this field is evolving. This paper really highlights it. Early models couldn't do basic stuff, and now we've got AI writing poetry, composing music, even passing, the bar exam.
It's mind-blowing. Makes you wonder what's next, right?
For sure. So at the heart of these modern LLMs is the transformer architecture. This paper calls it the core architecture behind these advanced models. So what's so special about it?
Well, the transformer architecture is like the engine driving these massive language models. And the key innovation is self-attention. Imagine reading a sentence, but your focus is shifting between words, depending on how important they are. That's basically what self-attention does. It figures out how words relate to each other.
So, like our brains do.
Exactly.
The paper gives an example sentence to illustrate this. The cat sat on the mat even though it was covered in crumbs.
It seems simple, but there's a lot going on.
Under the surface.
A transformer would break it down into individual words or tokens. Then, through self-attention, it analyzes the relationships. So, cat is the subject, sat is the verb, and mat is the object. It also picks up on the cat and it, understanding they're the same thing.
It's not just recognizing individual words, but understanding how they connect.
Precisely. And that's how they generate text that's grammatically correct, semantically rich, and contextually appropriate.
It's amazing. And then this paper mentions these mind-blowing facts about the scale of LLMs.
Yeah, it's pretty incredible.
It's all about parameters, which basically determine the complexity and capabilities.
Right.
And we're talking billions of them. GPT-3 has something like 175 billion parameters.
Right.
It's crazy. Roughly the same number of synapses in the human brain.
Yeah, the sheer number of parameters is mind-boggling, and that's a big part of why they can achieve these impressive results.
Makes sense. But building and training these things must require insane computational power.
It does. This paper gets into that, too. It's a massive undertaking.
Right. Table 5 shows the hardware needed to train them. It's like building a supercomputer just to get them running.
We're talking thousands of high-performance GPUs running for months. The paper mentions training Paul M, another huge one, took 120 days.
Wow.
On over 6,000 TPU v4 units. That's a crazy amount of power just to teach a computer how to, talk.
It's unbelievable. So we've got these incredibly complex models needing massive power to train. What's the payoff? What are they actually doing out in the world?
That's the big question, and one we'll get into next time. We'll explore those real-world applications. From personalized recommendations to breakthroughs in healthcare.
Can't wait to dig into that.
It's going to be fascinating.
Okay, so last time we kind of laid the groundwork, right? We talked about what LLMs are, how they work, that crazy scale. But now let's get to the real stuff. What are these things actually doing out in the world?
Well, you might be surprised. LLMs are everywhere.
Really?
Oh, yeah. They're powering a ton of stuff. You know those eerily good recommendations you get on shopping sites?
Yeah.
That's them. Cutting-edge research, too. Like in healthcare, even agriculture.
Wow.
The paper breaks it down by their core architectures. Makes sense, I guess.
Right. Like you got to understand the blueprints before you can appreciate the finished building.
Exactly. So, we have generative pre-trained transformers, the famous GPT series.
The ones everybody's talking about.
Yeah, those. Incredibly good at generating human-like text, writing stories, poems, even code. It's crazy.
Like they can actually be creative.
It seems that way. Often the fluency and creativity is as good as a human writer, but there are other types of LLMs too, each with their own strengths and applications.
Like BERT, right? The paper mentions that one a lot.
Yeah, BERT stands for bidirectional encoder representations from transformers. It's a mouthful.
Definitely.
But it's powerful, really excels at understanding context. It's pre-trained on this huge data set of text and code, so it can grasp those nuances of language that older models couldn't.
So if GPT is like the storyteller,
I like that.
BERT's more like the scholar, carefully analyzing and interpreting the meaning.
That's a great way to put it. And then you have models like T5. Stands for text-to-text transfer transformer.
The long one.
Yeah, but what's interesting about T5, it approaches all natural language processing tasks as text-to-text problems.
So everything, translating languages, summarizing documents, even answering questions, it's all about converting one string of text into another.
Exactly. And this approach has some real advantages. It makes development easier, deployment too, more versatile, more accessible.
Makes sense. So all these different LLMs, each with their own special talents. But the paper also gets into their real-world uses, and it's kind of mind-blowing.
It is, yeah.
Personalized recommendations, breakthroughs in healthcare, LLMs even helping with agriculture.
It's amazing. In agriculture, they're being used to analyze data from sensors, satellites, even social media. Farmers can optimize crop yields, manage resources better, even predict weather patterns.
So AI could be telling us when to plant our tomatoes. That's wild.
It is. And that's not just practical stuff. They're popping up in creative fields, too. Music composition, art generation.
Really?
Yeah. We're seeing LLMs create incredible art, write music, even screenplays. Makes you think about the nature of creativity, right?
It does.
Yeah.
Are we watching the birth of a new kind of art, where humans and machines collaborate?
Could be. It's one of those thought-provoking questions these LLMs raise.
But with great power comes great responsibility, right?
Yeah.
This paper talks about how important the ethical stuff is and how we develop and use these things.
Right. As they get more powerful, more widespread, we need to make sure they're used for good.
Absolutely.
We got to be mindful of potential bias, unintended consequences. Think about the impact on society as a whole.
The paper talks about something called multimodal integration.
Ah, yeah. That's getting into some futuristic stuff.
Sounds like it. What is that exactly?
Basically, it's LLMs that can process and generate more than just text. Images, videos, audio. Imagine an AI that can understand what's happening in a movie scene, generate music from a description, even have a conversation with you while reading your facial expressions and tone of voice.
That's intense.
It is. Could totally change how we communicate, how we learn, even how we think about ourselves.
It's exciting, but also a bit scary, you know?
I know what you mean. But let's not get too ahead of ourselves.
Yeah.
The paper also talks about some of the challenges the field is facing right now, like data complexity.
Okay.
The data sets used to train these models, they're massive. But messy, unstructured, lots of noise. Cleaning and prepping that data, it's a huge job. And it's super important for the accuracy and reliability of the models.
So it's not just feeding them more data. It's about the quality of the data, too.
Exactly. And then there's the computational demands. Training these huge models takes enormous processing power. It's expensive, energy intensive.
Not exactly great for the environment.
Yeah, that's a real concern. So researchers are trying to find more efficient training methods.
Makes sense. What about fine-tuning? The paper mentions that, too.
Ah, yes. fine-tuning. It's kind of like pre-training gives LLMs a broad understanding of language.
The basics.
Right. But fine-tuning is where you adapt them to specific tasks. You train them on a smaller, more focused data set.
So like taking a general purpose tool and sharpening it for a specific job.
Perfect analogy. But it's tricky. You got to find that balance between general knowledge and specialized skills.
Too much fine-tuning, and they might lose their ability to generalize. Too little, and they're not effective.
It's a balancing act.
The paper also mentions real-time responsiveness. That's got to be a challenge for things like chatbots or real-time translation.
Big time. LLMs are powerful but slow, especially when they're generating complex outputs.
Which is a problem if you need speed.
Right. So yeah, still work to be done there, making them faster, more efficient. And then there's what they call contextual constraints. LLMs have limited memory, you could say.
So they forget what they were talking about.
It can happen, yeah. Hard to maintain coherence over long stretches of text.
So no writing novels yet.
Not quite. But it's interesting to think about these limitations, right? They highlight that LLMs are still just tools, not magic.
Right. They don't have all the answers.
Exactly. And the paper talks about this too, the challenge of evaluating LLMs.
Seems like that's more complicated than just running some tests.
It is. Traditional metrics don't really work, and language is always evolving, so those static benchmarks get outdated fast.
So how do we know if they're actually understanding or just mimicking really well?
That's the million-dollar question. It gets at the heart of AI, really. How do you define and measure intelligence in machines?
That's deep. Almost like we're trying to judge a fish by its ability to climb a tree.
I like that. We're using our human benchmarks to evaluate something that might be fundamentally different.
So lots to think about there. But even with all these challenges, there's a sense of optimism in the paper, wouldn't you say?
Oh, definitely. The field is moving so fast, so much innovation.
It feels like we're on the edge of something big.
It does. A new era of AI, and we're just starting to understand its potential.
Which is huge. Revolutionizing healthcare, changing education, the possibilities are endless.
It's up to us to make sure we use this power responsibly, ethically. We need to be aware of the risks, but also embrace the opportunities.
It's a balancing act.
It is, but I think we can handle it.
And this research paper is a great guide, helps us understand LLMs better, their potential, limitations, what we need to think about.
It's been a really fascinating deep dive, wouldn't you say? We've covered so much, the history, the technology, the real-world stuff, even the philosophical stuff.
Yeah, it's been great. But we're not done yet.
Oh, right.
Next time, we'll look at what's next. The future of research in this area. The cutting edge of what's possible.
The future of LLMs. It's going to be amazing.
Stay tuned. All right, so we spent the last two parts really digging into these large language models, from how they started to what they can do now and all those real-world applications. But now, let's look ahead. What's next for these AI systems?
Well, this research paper, it points some really exciting avenues for future research. The field is exploding with innovation.
It really feels that way.
It's not just about making them, bigger and more powerful, though. It's about making them smarter, more efficient, more in line with, human values.
Right. And speaking of efficiency, we talked about all that computing power needed to train these models, which, not great for the environment, and it limits who can even work with them.
That's a huge issue. Researchers are trying to make LLM development more sustainable. One promising area is federated learning.
Federated learning?
Yeah, where models are trained on data from multiple sources. But they don't have to move all that data to one central location.
So instead of needing, one massive server farm.
Exactly. It could really cut down on energy use. And, democratize access to LLM development. More people could contribute.
That's amazing. And speaking of game changers, the paper mentions dynamic context handling. Remember we talked about how LLMs have kind of short memories?
Oh, yeah, the absent-minded professor problem.
Yeah.
They struggle to remember stuff from earlier in the conversation or text.
And that's because of their, limited memory.
Right. But researchers are working on ways to give them a bigger memory so they can understand longer stretches of text. Imagine a model that could summarize an entire book and still get all the details, the relationships between characters.
That'd be incredible.
It would. No more AI forgetting what it was talking about a few paragraphs ago.
Right. Oh, and there was something else that really caught my eye. Continuous learning. The idea that LLMs could keep learning, adapt as new information comes along.
Continuous learning, that's huge. We need these LLMs to stay relevant. Right now, most are trained on these static data sets, so their knowledge is basically frozen in time.
Like time travelers from the past.
Exactly. They have no idea what's happened since their data was collected. But continuous learning, they could update their knowledge all the time, keep up with new stuff, trends.
So they could, like, read the news and stay current.
That's the idea. It'd make them so much more useful in fields that are always changing, like science, finance, news analysis.
It makes sense. But as they get smarter, doesn't that also raise questions about, like, transparency and accountability? If we're relying on them for big decisions, we need to know how they're making those decisions.
That's where interpretable AI comes in. Basically, making their decision-making processes more transparent so we can understand the logic, the why behind their answers.
So it's like showing their work.
Exactly. Builds trust. Make sure they're being used responsibly.
Makes sense. And maybe another way to build trust is, focusing on collaboration.
Collaboration.
Yeah, like instead of seeing AI as a threat, think of it as a partner, a powerful tool to help us.
I like that. Humans and machines working together.
Right. To do things we couldn't do alone. But for that to work, we need good ways to evaluate them, make sure they're aligned with our values.
You got it. We need new ways to measure performance. Not just the old benchmarks, things like fairness, bias, societal impact.
That's a lot to consider.
It is. But it's been incredible exploring all this with you.
It has. From all the technical details to the impact on society, the ethical stuff, it's been quite a journey.
It has.
And it's clear, these LLMs, they're going to play a bigger and bigger role in our world.
No doubt about it. It's up to us to make sure it's a positive impact. We need to stay informed, have these conversations, and advocate for responsible development, Put human values first.
Absolutely. Well, thanks for joining us on this deep dive. We hope it's given you a better understanding of LLMs, what they can do, and how we can shape the future of AI. Until next time, keep exploring, keep asking questions, keep learning.